0. So it sent those updates back out to router 2. And vice versa. Router 2 was now able to send updates to router 1 via the serial 00 interface, and router 1 was able to process those updates locally and send those updates out to router 3. The other thing that we learned about is the broadcast statement. In this scenario here, we had to have it on. Without the the broadcast statement, if I do a show run interface serial 00 on router 1, I'll show you what I'm talking about here. The broadcast statement at the end of our static frame relay mapping commands. Without this statement on here, our neighbor adjacencies were not able to come up, and that's because the broadcasts weren't being sent out, the frame relay link. So we had to enable the broadcast statement on both sides of the connection here. Otherwise, we did see the scenario in which we were seeing unidirectional neighbor relationships. So in order to get the full bidirectional EIGRP neighbor relationship, we had to enable the broadcast statement at the end of our frame relay static mapping on both the hub router and, as I'll show you here as an example, on router 2. If we do a show run interface serial 00 on router 2 as well, we use the broadcast statement back to router 1, which was the hub. So very important. Without those broadcast statements, your EIGRP neighbor relationship was not going to come up in this point to multi-point EIGRP over frame relay network type, which is peering, where we're using serial interfaces. I'm sorry, the physical interface. Again, the split horizon command on router 1 here is no IP split horizon, and then EIGRP, and then the AS number, which is AS1, is the AS number we were running EIGRP in this network topology. Once we enabled that command, or once we put that command in, we had full IP reachability now. All routing tables are current and present. As we can see, we have the EIGRP learn routes on router 1. We have router 3's network on router 2. And on router 3, we have router 2's EIGRP network. So